Sir, is it audible to you?
Yes, sir, you're audible, sir.
Yeah, thank you. Thank you.
Welcome, dear participants. Program will be started in the next 10 minutes. Please invite your friends who have registered for this program.
எப்படியே கொள்ளலாம் முடிவு பண்ணிட்டீங்க.
Start, start, start. Good morning, one and all. The session will be started within 10 minutes, sir. So I request all the participants to join immediately. Sir, the session will be started within 5 minutes. I request all the participants to join immediately.
Sir, shall we start the session, sir?
Yes, ma'am, you go ahead.
A wonderful morning to one and all. I heartily welcome to the second day of 1 week online faculty development program on advanced algorithms and applications in AI and ML organized by Department of Computer Science and Engineering, Narayana Engineering College, Gudur, in association with AIMERS. I feel it as a great honor to welcome Dr. P. Venkateswar Rao Garu, Head of the Department CSC, Narayana Engineering College, Gudur. K. Vishwaksena Reddy Garu, Vice Principal, Narayana Engineering College, Gudur. Dr. V. Ravi Prasad Garu, Principal, Narayana Engineering College, Gudur, and all other respected faculty members from various institutions. Sai Satish Sir, CEO, Indian Servers, on Dr. B. Satish Kumar Garu, Professor, CSC Department, JNTUH. Now, I feel honored to have with us the Head of the Department CSC, Dr. P. Venkateswar Rao Garu, to address the gathering. Welcome, sir.
Thank you, ma'am. I welcome Dr. B. Satish Kumar Garu, Professor JNTUH, for accepting our invitation to act as a resource person for today's session. And I also welcome and thankful to Mr. D. Sai Satish Garu, President AIMER Society, to take the good initiative on conducting this FTP on AI and ML. I welcome to all the participants who have attended for today's program. Welcome you all, and thank you so much for giving me this opportunity. So over to Sucharita Madam to continue.
Thank you, sir. Now, I'm profusely elated to take an opportunity to introduce our resource person, Dr. B. Satish Kumar Garu. Dr. B. Satish Kumar Garu, BTech, MTech, PhD Professor, Computer Science and Engineering, JNTUH. Life membership in ISTE. Total teaching experience of 18 years. Positions held at JNTUHEJ as Deputy Warden, Hostel Manager and TPO. Boss member at Kakatiya University, St. Peter's Engineering College, GEET, CMRTC, JBIET. Oracle Academy official instructor for May 2016 for DBMS and Java programming. Trained more than 1,000 students in DBMS and Java with the help of Oracle Academy. Received the best appreciation from TAS, Telangana, for training students in Java programming. I am very much pleased to request Honorable Resource Person Dr. B. Satish Kumar Garu to proceed the session.
Yeah, that was wonderful introduction, and thank you very much for inviting me to this workshop, Narayana Engineering College, Gudur. I thank Dr. P. Venkateswar Rao Garu for giving this opportunity, a wonderful opportunity given to me. Even Sai Satish Sir, D. Sai Satish Sir, CEO of Indian Servers Private Limited, he contacted me earlier before talking to Venkateswar Rao Garu. He told me to handle one session, sir, regarding this workshop, 1 week workshop. Wonderful to see all of you. There are around 62 participants are there. Very nice to see. Before starting the session, I would like to say a few words about the Sai Satish sir. And let me start sharing the screen so that you can easily have what I have done. I think you were able to see my screen. Is it right?
Yes, sir.
Yeah. So I have conducted a program from 20th of 9th month last year. It's a 1 week program by HRDC or UGC, University Grants Commission, which is actually focused on especially advanced machine learning algorithms. This was the topic I have selected from 20th to 25th September. So I was in hesitation to initiate this program. Immediately, I got an idea. I have attended several sessions from Sai Satish sir as well. So luckily, I could able to lift the phone. He was while driving. He lift the phone and sir, give me some time. I will give more clarity on what to do, he told me. Immediately after maybe half an hour or 1 hour so, he called me and said, sir, we'll agree. How many sessions you want? You can see on the screen, most of the sessions are occupied by the like our Sai Satish sir team. I'm very thankful to him and like everything like you can see here like Tulasi ma'am or maybe there are after maybe 22nd to 25th almost sir handled the session and he involved himself personally in few sessions as well to deal with the to interact with the especially with the faculty members. It was a FDP program. It was great success with his initiation and support only, I can say, on this platform proudly. Thank you very much, Sai Satish sir. If you are there, I could able to. Are you there, sir?
Yes, sir. Thank you, sir. Thank you
Thank you
for giving us the opportunity to deal all these things.
Yes, thank you very much, sir. Once again, from this platform, I'm thankful to you. I'm very much thankful to you. And
Thank you,
with that, I couldn't able to handle any session, in these 5 days. Even they are not given opportunity to deliver any lecture in this because we are not allowed. We can conduct exams or something like, but we were not allowed to take sessions at that time. So the title you can see is Advanced Machine Learning, very beautiful content we have prepared. Even Sai Satish sir agreed in depth of with the particular tools also, which concept is suitable to which tool. So he knows very well to handle all these. You can see here linear regression, KNN, Naive Bayes, and ANN, SVM, K-means, like conformal recommender systems. All new topics we could able to introduce to the around 130 participants were there. Later on, it reduced to 70 members at the end. So few members they have not submitted their daily assignments and all. So with this brief, let me close this and let me start my presentation. Hope you are able to see now. Are you able to see my screen?
Yes, sir. It's visible, sir.
Yeah, thank you very much. Thank you. Now, let me start with the very basic fundamentals, few fundamentals of machine learning techniques, which are very well known. Yesterday, Nagaraj sir also given elaborately. Even I have gone through YouTube channel. It was very well delivered by him, Professor Nagaraj Garu. And I'm very thankful to him to have great introduction about so he's also in touch with everyone, like, like whatever machine learning techniques are there, or maybe he's a great scholar as well. And so maybe I named it as advanced machine learning techniques, but let us go in depth or maybe in depth about what actually algorithms are there, the basic concepts behind those algorithms. We'll be learning, and a few tools explanation may be given at the end at one, maybe, one slide. So let me start with this, maybe the agenda of my session, maybe overview of machine learning, and then few applications of machine learning. Then types we know very well: supervised, unsupervised, reinforcement, and semi-supervised, semi-supervised ensemble methods, and all those we'll be learning. And very importantly, gradient descent algorithm is their optimization techniques. Let us start with the definition. What is actually a machine learning? What do we try to do in the machine is we try to program and we expect a good output without any errors. But here in machine learning is a different case. We are making a system to learn itself. That is the main intention of this. So it means that you no need to program like explicitly, or to no need to hurry about the program what is there, or to do something. But we simply try to see the behavior of the system, how a system is behaving, and we try to take more inputs from that behavior, and automatically the program is created inside the machine, and then it generates accurate output, or maybe it predicts well. So that is the main intention. The Arthur Samuel in 1959 itself, he has given a beautiful definition. It is a field of study that gives computers the ability to learn without being explicitly programmed. So you can see the term explicitly programmable. And it is a beautiful definition and very latest definition by Tom Mitchell, one of my favorite authors. He explains very well in depth about any topic in his book, Tom Mitchell. And a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T is as measured by P improves with experience E. So the definition is definitely tricky, I know that, but learning from experience, what do you mean by experience, and what is this class of T, and what is this performance measure? So these three are the critical terms which are always coins in our mind in machine learning. So we must have experience with the database technologies to have what is actually the term E, and what may be the different tasks with respect to classes or maybe category wise. Right here, some class of tasks. Some class means we have to categorize the data, and then performance measure, like how accurately your results may be. So these are the terms we must have before going to the machine learning. So you may be expertise in our database, but that is completely different. That is completely managed in the background that we know, right? So this is a beautiful definition given by Tom Mitchell. I will give you an example about this. So the same definition given here: designing a spam filter. No, to classifying emails as spam or not spam, that is given as tasks T. Those are the tasks, number of tasks given, right? Next, without you label, watching you label emails as spam or not spam is experience E. So watching you label it or unlabel it. So whether it is spam or not spam. Now automatically the filter is filtering an image, filtering an email is very tough task. Right? It depends on your interests also sometimes. So if you are not willing to label that as a spam, right? So if it will be there in your inbox. If it is a spam, then it will go directly into the spam. So that is experience we have to learn. How many mails, or maybe how do you grade your mails, maybe labeling, or how do you grade, or how do you show your mails, like in your mailbox. That is very important. Then the number of emails correctly classified as spam or not spam, that is called performance measure. We know about tasks, what is our task, and then experience we have got, but this here, the number of emails correctly classified, that is performance measure P. So based on the experience of seeing your mails and filtering your mails, you are measuring them, you are giving an accurate number, you are predicting that these are the number of emails classified as spam or not spam. So that is the main interestingness of this machine learning. So that is why I told you a clear elaboration is given even more in the Tom Mitchell textbook about his first chapter, excellently described in what actually you need to do in the machine learning process compared to other textbooks. Okay, now this is the definition, again very simple definition given by Haldane. Machine learning is about predicting the future based on the past. So based on the past, you mean to what? Past, you will have a training data, and then you will have a model or predictor, and the system automatically learns the training data. In the future, what you are going to have is testing data, and then model the predictor. So here the prediction is happening. It is happening in two phases. If you observe past and future, it's happening in two phases. Past, what you are training data, learn the model, and then future, test the data, what actually, whether it is accurately given. Here performance measures takes place here, and then predict what you want to have. So this is a simple definition of machine learning, right? Now to deal with the small distinguishes here, yesterday sir has given a beautiful explanation on maybe applications and all, applications and the clear distinguishes of this AI, MI, and ML and DL. But here AI, we try to enable the behavior of the human being. That is the AI. It means that mimic. You are mimicking means you are trying to replica. You are trying to see your behavior as a robot. That is artificial intelligence mainly. Machine learning is different. The ability to learn without directly being programmed. Right here, in artificial intelligence, it is directly programmed. I mean to say here, and here in the machine learning, you are no need to directly program it, automatically predict something. Accurate results will come out when you try to have a perfect algorithm to measure. And then in the deep learning, the learning of underlying features in data using deep neural networks. This is completely different, which has got a depth in subject about deep learning. So there are so many topics compared to machine learning. Deep learning is a very critical subject to learn. And here, this is the relationship, a simple diagram, which is our ML is lying in between AI and DL. So here, the ML importance is more definitely. So which is involving deep learning, machine learning, and deep learning always, when compared to machine learning, it always like deep learning has got more weightage definitely, right? Of course, artificial intelligence, we know when it comes to work, or maybe when performance matters, then artificial intelligence comes into picture. This is a simple diagram to show you the relationship among these three. Right? These are the fields of studies, or maybe related fields of machine learning that you can see here: decision theory, AI control theory, game theory, philosophy, optimization, psychology, neurophysiology, and statistical machines, mechanics, and data mining. Of course, it is there. It is part of machine learning. Probability and statistics, the biological evaluation. So these are the main related fields, or maybe related areas of machine learning that you can see on the screen. Now, this is the way that we do in machine learning. Traditional kind of programming, what we do is to take a program or write a program, try to give an input that may be in form of maybe numbers or maybe characters. That is the data you give the program, and then you expect something to do with that program, and you get the output. Whether it is correct or not, that is, of course, it depends on the program you write. And next thing is, in our machine learning, here it is a very different case. We give data and as well as the output, right? Based on the experience, here we give sample outputs here, so that computer itself takes few algorithms to generate a program to predict the good results, right? So that is the interestingness of the machine learning here. Okay, I think you got the reference. Right here, a simple example to show you what we do in our machine learning. Like here, it's like a gardening. Like seeds are like mainly algorithms, nutrients are data, and then gardener is you, and plants are programs, definitely. Now, here you need to understand what is this seed. Algorithms are available. It means algorithms are available. You need to use those algorithms properly. Nutrients are known to us. Which nutrient may be useful to our body, that should be elaborated, or that should be thoroughly known to us. That is the data. What kind of data need to be given to generate or to generate predicted result, right? So gardener is the you. How do you do, or how do you manipulate your data? How accordingly you input your data? That is in your hand. And then finally the plants, those are the programs, right? Plants are nothing but it is a complete tree. You see, you are going to generate a program. So that program will predict you. It means that whether you want to have a, like kind of fruits you want, or whatever it may be, through plants only you can have. So this is a simple kind of example to explain you. Seeds are like algorithms, nutrients are like data, what you supply to your body, or maybe gardener, like you are the main reason to supply the data. Then plants are the programs, right? Now, types of machine learning algorithms. Let us directly now enter into the actual subject. What actually, these are the basic introduction about. We know these things very well about the machine learning concepts are everywhere. There were so many online programs going on. We thoroughly enjoyed really the online classes, but we should know what actually must learn in machine learning, and then how to proceed with the very simple and basic algorithms, right? So here the first term that we see in any machine learning algorithm is the supervised learning, right? Supervised learning, and then unsupervised learning, you'll see, and then maybe weakly or semi-supervised learning, or finally the reinforcement learning. So these are the four terms which always trigger in our mind to learn about machine learning. So what actually the supervised, unsupervised, weakly, or reinforcement learning? Supervised means, wised, like supervised itself, the name itself, it is saying that you have to think, you have to get the accurate output, like, training data includes desired outputs, right? Training data includes desired output. It means accurate output you will definitely get in terms with the supervised learning. It means training data is very crucial. I will tell you, there is one slide to show you about how much training data may be included, what percentage of training data is included in the machine learning process. That will, anyhow, that will show you. And unsupervised learning, another way of dealing with the data, that is training data does not include desired outputs. Okay. And here weakly or semi-supervised learning, training data includes a few desired outputs, which will try to give you the accurate result. Reinforcement learning rewards from sequence of actions. This is different. Reinforcement learning is based on the actions you perform. It may get fail, or maybe you may not get proper model, or maybe proper prediction in reinforcement learning based on the past actions, or maybe past sequence of actions that you may make. So simple example is, Sunsex. Sunsex, it was, I started investing, from 2008 or around. So it was around 11,000 was Sunsex was. Now it is 55. Can you imagine that? 55,000, 40,000 increase in the Sunsex abruptly. So these are the things happens that we must be able to predict. So for those kinds of analysis, or maybe it reinforcement learning may be perfectly suitable method in machine learning process, right? So these are the four popular machine learning techniques, and not algorithms, techniques which are there, which are all algorithms are falling under these four categories only: supervised, unsupervised, semi-supervised, and reinforcement learning methods. The mechanics is very simple. It is to predict the analytics, right? This is machine learning job is to predict that something is going to have, or maybe some accurate result you are going to get. So what we need to do is collect and prepare the data that we do now normally in the data mining process also. What is this collection and preparing the data? We forget the basic fundamentals while collecting and preparing the data. So collection may happen in several forms. We need to categorize, or maybe we need to keep in a particular way to deal the data, and prepare the data in such a way that it is going to give you the accurate. Maybe let me give you some simple example. There may be 10 attributes, or maybe 10 parameters may be available in a spreadsheet, or maybe in kind of Excel sheet. You collect only few samples from the 10 attributes, or maybe 10 parameters are not necessary to analyze the data. Few sample, or maybe few columns may not be related to your to analyze. So you skip those and collect the appropriate data. That is very important before any research. For any research also, it is very important to collect the accurate data, right? And cleaning, filtering, then transformation and aggregation. So this is the process of, again, machine learning. Cleaning is such a big task that we know. No duplicate should not be allowed. Then filtering should be done. And then transformation must not happen. And then aggregate the data in such a way to deal. And analyze data and identify trends, right? You have to analyze the data, right? You have to analyze what kind of data you are going to have, right? And that analyze and then identify the trends. Build models with machine learning. this is a very critical portion in our ML. You have to build models according to the data that you have analyzed, which category it is falling, supervised or unsupervised or semi-supervised, or maybe reinforcement process, which process is suitable to have or to build the model with machine learning. Then test models to ensure the accuracy of predictions. You have to test the model as well, right, to ensure that accuracy of the predictions. Accuracy means maybe 100% may not be there, but 90 to 100% you may get the results. Use model to predict future behavior, right? So this is the mechanics of machine learning process. These 6 steps are very important to understand always to predict something, right? These are the algorithms, very popular algorithms, which are mentioned everywhere, of course, that we know, which are always we try to see the algorithms that regression, classification, and clustering. These all are very popular names. We focus on the supervised and unsupervised mostly. That is in that we have regression. Regression is having linear regression and logistic regression, very popular. And then classification, we have decision trees, random forest, naive Bayes, support, that is SVM, support vector machine, and then neural networks, right? Neural networks, which is of course a continuation of our deep learning. Deep learning mainly focuses on neurons and all. Okay, and then here recommendation is user based and item based, right? This is the recommendation system is especially user based will be there, and then item based will be there. Now here, what is this actually we are trying to do? What is this we are trying to do in supervised learning? We are predicting a model. We are predicting the future with sample inputs by observing the behavior of the existing data, so that you can have a proper guidance towards your work. That is the main intention of this machine learning, that we know. So what most of the times we try to compare the results always. Remember, we try to compare the existing results, so that we'll be trying to pick up. While comparing or maybe while doing that exercise, you need a background analysis of that. That background analysis can be used through regression techniques and classification techniques. Of course, clustering is also there, right? So this background checking process is happened through these techniques only. There is nothing in it. So that you have to classify the data properly. You have to follow some kind of linearity or maybe logistic kind of thing, and then maybe form a group and try to do some things with the model, and then try to generate try to have a prediction about your results. So this is linear logistic, that is linear regression and logistic regression. Classification, one of my favorite topics in machine learning. I have started my PhD with the classification only, and that was excellent. And then clustering, of course, k-means and k-nearest neighbor, which are falling under unsupervised learning, right? Supervised and unsupervised learning. Clustering is a kind of clustering is of course it's not the concept was very old, but we could able to keep in a proper to understand the behavior of the data by grouping things. Grouping the things is very easy, but grouping the things and understanding the features in the group. Now, let me give you an example. If you open any application of Amazon or maybe Flipkart, if you open, you are able to categorize the things very easily. Mobiles or maybe gadgets kind of thing, or maybe clothes session or something. You would able to categorize the things very easily. So because of these clustering mechanisms. So there is a clustering mechanism and then classification mechanism, and as well as some kind of decisions may be taken at your end by looking at the data. So okay, so these are the very popular algorithms which are given, these algorithms were explained with respect to tools in my when I have conducted the this workshop on advanced machine learning. These all concepts are explained neatly with a particular tool. So that elaboration is required for you also, right? I think Sai Satish sir will help you in this regard. There are experts, wonderful programmers are there. Excellent team is available with him, so that you can contact and have session on these particular sessions with a particular tool, so that you will have an excellent idea, right? So this is about the algorithm, brief introduction about algorithms. Now let us have what is the supervised learning. Focus on supervised learning, which is of course a labeled data, right? Labeled data are used in train the algorithm. What is labeling and unlabeling? Labeled data. Labeled means here the data is proper. Male means male. Female means, so that is the gender is, that is, for example, that means sex is given as a name, and then male and female. So that can be shown clearly. For example, the date of birth column is there. Date of birth is meant for date, year, date, month, and year. So like that, labeling of data must be clearly done, so that it is used to train the algorithms. It becomes very easy. Labeled data is taken here, especially. Then algorithms are trained using annotated data, where the input and output are known, right? You know the input, and then output is also but prediction is depends on the model that you generate. Use the data patterns to predict the output for new data labels. Okay, that is the use the data patterns. What is this data pattern? The data pattern, how your system is behaving to exact prediction of your data. That is only the diagram you can see here. Input the raw data. Then you see in the supervised learning mechanism, what it is happening, supervisor, then training the data set, then desired output. Both are coming towards the algorithm. It is preparing, then it processes, then it gives the output, that predicting the right model. It is mainly used in predicting the model, right? So this is the process of supervised learning. I hope you understood. Like supervised learning is a process used for labeling the data, right? So labeling the data, training data set is very crucial here. Of course, we use here using annotated data. We are annotated means that is labeling only, right? And then input and output are also known to us, okay, in the supervised learning. Here, another one is the regression. A regression is when the output variable is real or continuous value. Output variable is real or maybe a continuous value. The examples you can see, predicting age of a person, right? We have to, now your age is around 20. So what may be the age after 20 or 30 years? That is easily calculated. That is regression. It means that, of course, accurate results will come. So today, what is the date? It means tomorrow you can say easily. That prediction happens. So these continuous values never get changed, right? Predicting nationality of a person by observing the behavior or maybe some characteristics of a person. Then predicting whether stock price of a company will increase tomorrow. So recently, I have observed predicting nationality of a person by, by speech recognition. I've seen recently, like by speaking, by talk, where you belongs to. That system is also available. That you try to speak to the system, and you try to analyze where you are from exactly. Maybe 1 or 2 parameters are required. Even I saw recently somewhere in the blog, right? Predicting nationality of a person. Then predicting whether stock price of a company will increase tomorrow. This is a difficult task of the regression. Of course, that we cannot. It is very difficult to analyze the stock market price every day. But tomorrow, what happens that we don't know. It may fall directly 10,000 or 20,000. It may fall, but we should be able to predict. Like if you keep your money in this particular area or maybe particular company, so that it may increase. There are chances are there. Like that, right? From features to predictions, you see that what regression is doing. You can observe here. Input features derived from data, features are derived from the data, whatever you give, and then regression learn X to Y relationship, what kind of intelligence or maybe what kind of model you are going to expect, that predicting Y, then continuous output or response to input. So this is an excellent model for especially real and continuous values, that we know real and continuous values. So if it keep on goes on, then you have to, the main thing is regression learn X, X tends to Y. So that is very important. That relationship is very important in the regression. So that you have to learn what kinds of parameters may be suitable to predict in the regression accurately. That gives you the learning model from X to Y relationship. For example, today is the date. So for example, let me tell you, today is the price of some product, maybe for example, mobile phone. If you take mobile phone, today price maybe 50,000. After 6 months, you can easily guess that definitely price is going to reduce, because new models may come, 40,000 or maybe 35,000, it may come down due to its maybe the features, lack of features or something. That can be easily, you can monitor and you can take decisions. That is called an intelligent system, right? So these are easily predictable things. So in that way, regression is nothing but repetition of your work. Simply I can say repeat the thing and try to get the accurate output, right? So this is about the regression. Then one of the important and my favorite is classification. So classifying is of course, there are so many examples to classify. There are some things which we cannot we cannot predict, but they get a lot of scope on it. Like classification is the process of categorizing a given set of data into classes. Categorization is a very difficult job for any set of data. So you have a lot of data in the available, of course, but how to categorize the data and make it into classes, right? A group of classes, maybe this is one group of class, this is one group of class, this is one group of. Let me take a simple example. If you are in a class and you are trying to observe students, maybe 60 odd students are there. Those 60 odd students, you can easily categorize the students, like excellent students may be less than 10, right? Average students may be more than 30. Like that, you can easily categorize the data. But how do you categorize, or maybe how do you classify these this data? So first of all, understanding a data set, it's a critical job. Understanding a data set and the parameters of those data set is a critical thing, right? Identifying a parameter. Like there is one key term in classification, that is hyperparameter was used. Hyperparameter. That was an excellent term. Hyperparameter, which could be able to activate so many things, right? So we'll see that anyhow. Maybe it is there in the slides. So that is the classification. Perform mapping function from input variable to discrete output variables. So see that point carefully. Perform mapping function from input variable. The input variable is given, and then to discrete output variables. Okay. Performing mapping function from, you see that input variable to discrete output variable, right? You give input variable, you will see the discrete output variable, what actually you need to categorize or classify the things, right? This may be in the form of structured or maybe unstructured data, right? The input may be structured or maybe unstructured. You have to prepare yourself to classify. Main goal is to identify which category or class that the new data will fall in. Now, this classification and clustering are two different scenarios. Try to observe here. Categorization according to the behavior of the data is the classification. Clustering is different, a group of items which are having similar behavior in the data we kept in the clustering. Classification is to understand the behavior of the data and then keep as a class or maybe as a set, right? That is different. This is different. Don't club. So even I confuse a lot about classification and clustering, right? Please, classification is different and clustering is different, right? You can observe a simple example. A classifier is used inbox and spam folders are kept aside to understand the mail directly. The mail is given to you, then it classifies as which mail should be there in the inbox, and maybe where should spam should be there in the mail, right? Then supervised learning, a simple example, which uses, of course, the labeled data that we know, a finite set of labels, that is a classification, which we know. Like you observe here, those are not the images simply kept. Those are the images. Apple are two kinds of things, red apple and green apple is there, but though both are falling under apple only. But green banana and yellow banana, both are falling under the banana category only, right? That is classifying. So can you say that by looking at the green one, sometimes if you see individually that, you may not easily identify that as an apple, right? So there is a problem with the classification with this kind of labeling. So that is why labeled examples only are good at supervised learning. Right, supervised learning and supervised learning techniques. Right now these are the applications that we frequently face recognition. That this is a face recognition and palm recognition. This is my research area. I have implemented an algorithm to identify a fake person in a group of people. With this face and palm, I complete. That is multi-level recognition system I developed in my thesis work. So that face recognition and then character recognition. Character, of course, very easy, but spam detection, that there are so many filters are there, so easily we can categorize. Then medical diagnosis, right? Then biometrics. So these all are the applications of very critical applications of the classification, right? Then supervised learning, the regression. The first one is what we have seen. The next one is the regression. Regression is nothing but it is a real valued. Now the label is real valued, right? The label is -4.5, 10.1 is given, 3.2 and 4.3. Now you can easily say that you cannot identify what is actually it is. The labeled here, the label is the value. Label is based on the values you are going to calculate. Is a real value is given over there, so that you can get accurate results. That there, what you are trying to label it. Labeling means what? You are naming it, you are texting it. But here you will give in the regression to accurate results. You will be trying to give a value to the particular item and you try to see the results, right? You are giving so that 10.1, whatever the category or maybe anything is there, so it is some kind of green apple. -4.5, it is labeled red apple. Like that you can easily categorize, right? So this is the supervised regression example, right? Car prices, of used car, price of a used car, the y is equal to wx plus w0. X is the mileage given here, and then y is the price. Used car, you can see it is always downfall. You can see here it is down. The price is very high. Based on the mileage, you will try to purchase it, right? It is definitely it goes down. There is no chance to go up. That is why regression is suitable for such applications to predict. Like today you have purchased a car with 10 lakhs, and after a few years it may be around 6 or 5 lakhs, definitely, depending on the mileage and usage of your car. Right? There are X is car attributes and mileage, and then Y is the price that you can easily predict. Maybe regression is a suitable example to predict the car price after maybe few years, right? Then predicting the the value of a stock, right? The value of a stock. What is that? Of course, application. There are so many. Epidemiology. This is the wonderful topic which is recently happening. Epidemiology, the study of the distribution and determinants of health related states and events in specified populations, right? So this is an excellent topic for research those who are doing research nowadays in supervised learning, right? So you can observe the study, that is the scientific, systematic, and data-driven of the distribution, the frequency and patterns, right? Frequency and patterns are two distributed, of course, that two distributions, that is very difficult to analyze the patterns and frequencies, because maybe epidemiology, especially, observes the behavior or maybe the health conditions of a particular person, or maybe the area, a particular area related kind of thing, which is, in this pandemic situation, everyone is using those kinds of analysis. What may be the, if you just simply type in the Google, like, what may be the cases of COVID nowadays, that you can see directly a graph, how it is increasing or maybe decreasing. Those kinds of patterns can be recognized easily in the regression applications. So that is very important application nowadays. In the, even in the pharma also, they are trying to identify various things. Now here, car or plane navigation, that we have GPS system to follow, definitely. That where is vehicle identification has become very easy nowadays with simply monitoring GPS. The temporal trends, weather over time, temporarily you can identify some kind of the season wise applications can be calculated in regression, right? So among all these, epidemiology is one of the best one. And one of my research scholar is trying to he is trying to see the, right, in the health related states and events, right? Of course, it's not about the diseases. It is given there, not just diseases, health related states and events. It means that, for example, particularly India, if you take how healthy they are and what kind of data must be taken to analyze, right? So that kind of study we are trying to have, we are doing it now. And then with this kind of state, like, Indian country state, and then compared to other state, how they are healthy, maybe with the China or maybe some other countries, how healthy we are, like in what aspects we are healthy, and what are the weather conditions that apply towards a particular country to make them active or to avoid such COVID or maybe such diseases. That study we are trying to have, and we are trying to build a model for that also, right? And try to have an application. And also I'm focusing on a specific pattern, like, the another one is the distribution of the the pattern means here, especially we are trying to identify a age by age, like, age is the pattern we have taken, some kind of age group, maybe 20 to 30 years kind of age, and then 30 to 40 years, 40 to 50, 50 to 60, even that age kind of category or maybe classification taken, and then we are also studying that as well. That we are getting a trouble in accessing the data, or to relevant data, we are suitable data we are unable to get. Few data is available, but it's not accurate results we are getting with our specific model, right? Next one, like unsupervised learning, right? So that is about supervised learning, the regression topic we have seen. Then next one is the unlabeled data are used to train the algorithms in the unsupervised learning, which means it is used to data in the historical labels, right? We see that has no historical labels, definitely. The purpose is to explore the data and find some structure within. Second point is very important, even in the in supervised learning also, second point was very important. The purpose is to explore the data and find some structure within, right? So what kind of maybe a structure it is following in the data, that is we are trying to explore in the unsupervised learning. Of course, it is unlabeled data, right? This learning technique works well on transactional data. right? Then it is mainly used in descriptive modeling. You can see the model, that is input the raw data, then algorithm that you see, that algorithm works. Then before that, what you have to do is unknown output is given, no training data set is taken, no training data set, right? It means that you don't know what kind of data you are dealing with. Then interpretation, just you interpret the results, then process it, apply some algorithm, then process, then you see the output. So how effective this is, right? How effective this is. Wait, I don't know, my system got stuck. Okay, right. Right. This is it audible?
Yes, sir, you're audible,
Yes.
sir.
Yeah, fine. Thank you. Thank you. Unsupervised learning, you see unsupervised learning, given data, that is, but no labels are given here. There are no labels. In regression, we have given the value and we have used label data with the name is given as a label like apple and all. Here, unsupervised learning, we don't know what item it is actually, right? So well, there are no labels at all in this in unsupervised learning. They are the applications like learn clusters groups without any label, or you will trying to have a cluster, you don't have any name also, but you need to label it later on. Then customer segmentation, that is grouping, that group the things together. Then image compression, then bioinformatics, then learning of motives. So this is about the unsupervised learning applications. Okay, now these are the algorithms, machine learning algorithms, which are given so far, like discrete and continuous, supervised, and this is excellent distinguish you can see in the supervised and unsupervised learning. Discrete is a classification and then clustering. Then continuous is regression and dimensionality reduction. Okay, dimensional reduction is also one of the best example to show. So we have seen classification, what is actually, then clustering we'll see anyhow, then regression also we'll see. This is how it is categorized. Main four things which are given on the screen: discrete and continuous. You must know about the discrete and continuous values and where there are foreign. Discrete, unsupervised learning, it is becoming cluster. Then continuous, unsupervised learning, dimensionality reduction. Continuous, supervised learning, regression. Continuous, supervised learning, classification. Continuous, that we know very well, right? Now let us see what is the simple example of a classification. That breast cancer is taken as an example here. You see here classification problem, which is here discrete values, output is example 0 or 1. Well, this is whether it is malignant or not, to check the algorithm, to analyze the breast cancer of a particular patient. That 1 is yes and 0 is no. 0 is flattened and here it is on x-axis and y-axis it is given as 1. Benign, here it is whether if it is benign means what? Of course it is in the initial stage, or maybe there is no effect at all, right? There is no effect at all. So that is the prediction that is given in a simple example here, and that is about the classification problem. Here multi-classification is there. The interesting thing is multi-classification is given, and with the tumor size, based on the tumor size, you are going to identify whether it is malignant or benign. So these are the two things, right? Multi-classification, we use 0 or 1 or 2 or 3 here in the multi-classification, and here it is classification. So classification, we see that always classification may happen in any number of groups. Okay, but we try to see, when you try to analyze a group, we try to maximum or maybe any kind of application, we try to see only in one classification is enough for a particular data set. We may restrict ourselves, but sometimes it is required to observe multi-classification. Multi-classification means, let me give you one example. If there are 10 parameters are there, There are 10 parameters are there. Maybe 135 is classified as 1, maybe 268 is classified as 1, and then remaining all are classified as 1. Here we could able to form 3 groups. Right? We could able to form 3 groups. Based on that, so that is why supervised learning, it is an excellent example of classification. Right? If you take that 3 groups in 10 parameters, it gives excellent results. So you can predict the results easily. So that is how classification and multi-classification, multi-class classification are very important. We must not restrict our data set to have a single classification. Let it be have a multi-classification, multi-class classification, or multi-classification, so that your results will be accurate. That is very important. We always focus wherever there is a data, you consider data, you take few labels or maybe few parameters from it and try to group the things and have one classification. Like we know very popular example in retail store, we go to store and we try to find some kind of, for some kind of kids wearing or something. If you go there, if you observe, if you keep a beer besides that kids wear, so immediately beer is also taken. So for, who is that person taking? The father is taking that, beer, and for kids he is taking the unexpected nature of the, unexpected nature of that combination. So those multi-class classification will help you to predict predicting the particular items may be sold, or maybe particular items may be sold in this time. That is the attractiveness that you can do in this through classification. Okay. Next one, this is the image classification. I think please try to have there is a video here. Please try to listen to this video. You will be excited. Yeah, that was an excellent example. Really, I inspired by looking this, this video. All are blind people. They are trying to observe, or maybe they are unable to see the picture, but they see the particular, importance of this picture. People are there. Behind that, there is a sea, and there are 6 people are in and around, and that guy is wearing something, and the picture is able to explain. That is image classification. What are the things need to be explained when there is a picture? That is an interesting thing in this video. And then there is a picture, what you need to explain to the blind person, right? That we should focus on. It is difference. The difference will be the common points. First, we need to identify the common. For when you see a picture, your common point is that is there anyone surrounded by you, or is there any sea surrounded by you, or is there any building surrounded by you, right? Who is along with that person, right? Where it is shared actually, and what kind of which situation, or maybe which place you are there, or maybe hill, or you are on the top of somewhere, or maybe on the building, or maybe in the hotel or somewhere. It should be able to explain the things. The image should speak, so that like this results will come definitely. Right? This is an excellent example. Yeah. After this, there is another example, spotting eye disease. Of course, if we go into eye, there are so many. You can see, you can watch video here, you can see later on. This it can able to recognize 50 sight-threatening eye diseases. Definitely a small, how pixels are generated and how very difficult to understand the eye structure. But classification can easily do the job. Very typical applications are solved in the classification itself, right? And here face recognition, which is given Facebook auto tagging, that enabled or maybe disabled. If you can if you could able to enable, like definitely they will try to see, and you see wherever you have taken pics and all those, it will take the background and it will try to show you some kind of features, or maybe it will try to explain the opposite person, you are somewhere in this place, right? So this is Facebook auto tagging, right? This is a face recognition. Face recognition is speech recognition. Speech recognition, I told you already, speech recognition is one of the very difficult tasks nowadays to identify. Of course, we are able to identify easily the behavior of a person by speech, but the speech, it is very difficult to understand where that person belongs to. That if I am talking to you in some, in a way, I'm as an Indian, so you can easily say that this fellow belongs to India something. So if I stay in America and come back here and talk to you, then you may not identify easily by looking at my speech or maybe my talk. So that was a very difficult, very difficult task. So we need to focus on each and every parameter of that. What type of parameter may be taken to recognize accurate speech of a person, right? Then predicting after shock patterns, right? After shock patterns is very, of course. So how it has happened, that is only the thing. Maybe you can see like tsunami is there. How it has happened, you can just guess. The rain has flown, but the water has come from sea to this place, and this way it has gone. Like that only the patterns may be identified easily through this, right? So that was an excellent example of classification. Next one, continuous the regression, right? Right, regression, housing price prediction, that you can see here. There's a simple example to show you, right? Of course, it definitely continuous value output regression problem. It will definitely increase. Last year, if you have taken for 2000 or 3000 something, like it definitely increase. There is no coming down of any housing construction or maybe any land price. Right, so sometimes it happens, but mostly 90% accurate results will shows that there will be a raise in the housing price, definitely. So that is what this example, the regression problem or maybe regression is a suitable model to predict it, right? Next, this stock market analysis. Already we have seen one example, right? So the weather prediction also, I gave you an example to understand, right? Right here, so this may not be, this video is not having any audio. Let me show you this one to have an audio. Yeah, I think you got it. So this is very difficult, identify, recognize the face in the background and move your filter or maybe facial mask according to their movements. So it is not an easy task. They have started, one company has started. So they were very popular at the time, very excellently designed. And another one, you can see just, you can observe here, human pose estimation right here. Let me show you this video also so that you can understand. There is no audio, but you can observe like how dance movements are there. The movements which are happening accurately, they are keeping their steps or not is observed here clearly. You see how he is breaking? He is breaking the entire body into, break the surface into parts. And you see that one area, first area, that is 5 million correspondences. That you see how they are pose estimation. You see how human pose estimation, how do they sit and how do they move. That is the input image, part index, U coordinates and V coordinates are taken. You observe V coordinates and U and V coordinates. In the middle there is a guy who is having towel. He's keeping towel on his hip. You can observe even that is also showing in the image. Right? These are the very difficult tasks to identify the movements and all. Right? So this is another one. And next one is the discrete, that is clustering, unsupervised learning. Very important one. We should not neglect clustering also. We know the importance of classification and regression. There are two, these two are very popular to understand the behavior of the data. And next one is the clustering. So in supervised learning, we do these things, and then unsupervised learning, you see that it is falling under unsupervised learning. We are trying to form a cluster. In unsupervised learning, it does like this, like x1, x2, xxx. Of course, that is there in the part of the data, but we are keeping that as a group unwantedly. Wantedly things are circled here, but here wanted and unwanted things are grouped, like neatly in the unsupervised learning as a cluster. So that is the importance of thing. Cluster means here group of relevant things keeping together at a particular place, right? So a particular place means to analyze the data, you may get something, even though there are some diseases. Let me say there are some diseases. COVID patients are there, non-COVID patients are there. COVID patients are clustered, non-COVID patients are clustered. Non-COVID patients, so COVID patients' behavior may be analyzed easily. We should not, the data won't be waste anytime, right? So this is nothing but the clustering has got more importance than, maybe classification or maybe regression for a particular analysis purpose, because you are grouping it and then you kept aside that you confirm that these are the things are going to be used in future for some prediction. Right? So for that, you need to properly cluster the data. Okay, so that is what we are trying to do here. Google News, one of the popular, they try to cluster example. And then this is a very typical example to understand clustering DNA microarray data. Right? You see individuals and genes. Individual data is taken and then how genes are there is taken. It builds groups of genes with related expression patterns, also known as co-expressed genes, right? So this is how the data, how genes are there of a particular individuals is analyzed. There is a microarray data, DNA microarray, very difficult data to gather, right? Now, the another one is organizing computing clusters at one point, then social network analysis, and then market segmentation. Okay, and then astronomical data analysis, market segmentation. I want to give you one example here. In the market segmentation, who are the persons, who are the most interested persons to invest in stock market, or maybe who are the most interested persons to reach reach the cinema halls, or maybe who are the most family members who visit the cinema halls frequently. So the data can be taken easily from where? You can easily take from the data from maybe book my show kind of thing, or maybe online platform ticket booking, wherever it is, wherever those are there. From that you can collect the data and analyze the data confidently. So these are the things that will definitely useful to predict or to design such a good model or to predict good results. Now, for example, there is a movie is going to be released, that Bhimla Nayak movie is going to be released in this month only. So what may be the prediction of how many persons, or maybe how many persons are going to visit the theater, right? So like that, you can easily predict that if the all situations are good and COVID is in control, then they can easily release in so many screens, and then so many people may watch it easily, and then have good profit among about that movie. That prediction is very important according to the situations where we are in. So that is what the clustering always does. Clustering may not work in some situations where you cannot predict easily. So this is going to happen, right? So here in and around in Telangana area, then Samakka Saralama Jatara is going on. Most of the people are in and around Warangal and Hanbakunda now. So lakhs of people are there. They are trying to pray goddess Saralama. Nearby that there are so many. That prediction is already done. Based on that prediction, facilities and arrangements were made, right? So that prediction can be easily made for some situations. So I need to say it is a cluster now. It is a kind of cluster now. That cluster need to be focused much, without any traffic jams, or maybe any COVID patients. COVID checking centers should be there, hospitals must be maintained, right? Right. So all these things, the needs of the people must be kept over there, maybe water bottles and all those. So these kinds of analysis must be done before that. So the prediction is very easy when there is a cluster kind of thing. That is what I mean to say, right? Next one is dimensionality reduction. This is very interesting one. Before that, please have a look into this video. Here it needs a shape modeling in a complete, like in a model, in the shape modeling, which is actually to understand the shapes of a particular country persons. Like this shape modeling was very interesting. They have taken samples of few persons from that country, and they observe like this is the shape of that, maybe normal size is that, but accurate results. Maybe if you take Indian culture, there may be some kind of fat and all, we may easily guess. But in USA and all, those fat guys are very less, but of course there are there. But they don't take rice and much all. Based on those analysis, shape modeling has taken into. That is only the example given over there. Now this is a super example of dimensionality reduction about the 3D face modeling. Please observe this carefully, this 3D face modeling, please. Yeah, so that was the main aim is here to have the parameters. The key is here is that there are 3-4 points were there here to understand the smiling face, and the dull face, and the combining the painting, like smiley face to the dull face, and bony bone face, and then fatty face, and all those things can be recognized easily through a single parameter. So, okay, that is of course the ultimate goal of the 3D face model. Then only one particular parameter should be there to identify any kind of this single feature, right? So this 3D face modeling is an accurate, this can be happen only through the dimensionality reduction. That is the main intention of this video to show you. Dimensionality reduction is to identify the of course images, and all images means again X and Y axis pixel ranges are taken into consideration. With those values only you will be trying to deal the algorithms, right? So in this dimensionality reduction algorithms, you see that there is a line. Of course there are points identified like in circles X1 and X2. We try to make them in a particular line, we try to reduce that and keep in a proper way. So unnecessary things may be avoided, only necessary things are analyzed clearly to predict a good model, to predict the analysis. That is only the main intention. You can observe here arrows are there, those arrows are going towards that particular middle point, right? Right. So that is about so these are the machine learning intelligence 3.0. You can have slides. Of course, there are so many are there. Here are the applications, very popular applications: healthcare, language translation, online fraud detection, online customer support, email, spam and malware filtering, social media services, virtual personal assistants, prediction while commuting. Like these are so many applications are there. These are not, of course, there are so many applications already developed, but still in developing stage. Of course, the last one is very interesting. traffic prediction, then that is online transportation networks, which is very popular nowadays. Of course, the vehicle each and nowadays we need to keep, to track easily. A vehicle must have some kind of tag. In future, they are going to keep one tag for all vehicles to understand where is your vehicle and how fastly you are moving. That is also coming. That is also going to come in future. Okay. Of course, we have smart speakers, smartphones, and mobile apps, which is already going on. And another challenging is face recognition. So many things are happening nowadays in face recognition. Even I focused when I was doing my PhD, I focused on the face, face transformation. Like, if my face is, I transferred my face into some kind of hero face, or maybe I change my face to hero face, and then how I can be recognized easily. So those things are also very critical. So based on those also, there's so many things are happening with this face recognition, right? So once a face is unrecognizable, then what are the alternatives to identify a person? Maybe a voice. Voice is the key. Voice becomes very key in future, right? When you want to open your mobile also, your voice must be accurate to reach the phone, right? Only open my, of course, Google speaker is there. Google speak that, it could able to recognize your, like your language properly, and it responds to you according to your input. But opening or maybe opening an application through a voice is again, it's a big challenge. Whoever speaks, if it opens, then there is no use of it. So your accurate voice should be there, and it should be recorded in it, and then open it, right? There were so many failures even in the face recognition, right? In the face recognition in the recent, like 3-4 years ago, if you keep any face in front of your phone, the phone is going to unlock. But later on, they made so many changes in it, and it is now the perfectly all most of the mobiles are recognized, only their personal phones only, right? So there are such applications, beautiful applications may be seen, right? From this onwards, we are going to deal or maybe see in the what actually the content which is there in all supervised, unsupervised, or maybe reinforcement or semi-supervised learning techniques. In a technical way, we will see now from now onwards. Now, sample illustration about machine learning is to have data and then generate a function, then predict something. So that is a simple one to have. And even I was focusing on nowadays errors, some kind of measurement errors, right? So these errors are maybe useful to identify the accuracy of your predicted results. Those are especially to generate nearly accurate, not exactly, but those functions are very critical to apply in a particular situation. Okay, those functions are very difficult. Of course, we know that we have a very very good matrix, right? That matrix gives true positives, true negatives, false positives, false negatives, and all those kinds of functions must be generated according to our model, right? Whatever we introduce the model. So of course, I have given you classification, clustering, regression, and anomaly detection. Through clustering only it happens, right? Now machine learning algorithms. Let us now focus on the, of course, very basic algorithms I have kept, right? But not through tool. I could not able to explain. Only Sai Satish sir can help you with the tools and accurate results, and correct data set is also having. And linear regression, the first one. It is a kind of predictive modeling where the possible output for the given input X is predicted based on the previous data or values that we have seen. Simple definition. The main aim is to find the best fit line which minimizes error. And the best fit line should be identified So that wherever, of course, nearby points, wherever are there, y is equal to mx plus c. Very simple equation. But it is used to predict values within a continuous range rather than trying to classify them into categories. So categories cannot be possible here. You can see in the example x and y values. There are some samples which are randomly going, but we could able to have some kind of some kind of analysis, or maybe by drawing some kind of line. So which are within that range only, they are there. Right? Within the range, you can observe clearly the range. Right? 5,000, maybe around 3,000, 30,000 range to some kind of 1,10,000 range something. Right? This is the range in between from 2 to 15, 2 to 12, some kind of x value. Right? So that prediction can be easily done. And importantly, the known parameters are used to make a continuous and constant slope, which is used to predict our unknown or the result. Okay, so continuous and constant slope. So there are two types are there: simple regression and multiple regression. It is characterized by one independent variable. Only one independent variable will be taken. Multiple linear regression, it is categorized as multiple independent variables. Independent variable means what here? Independent variable. Only one variable is going to calculate your values. That is linearly. And then multiple means you will have so many variables, and then it is very difficult in the linear regression. Multiple independent variables handling is difficult when algorithm is running. Right? When you run your algorithm, it is very difficult to consider the multiple independent variables. Right? Now the equation of linear regression is y is equal to ax plus b. A is the slope of the line, a. Then b is the constant, that is y-intercept, and where x is equal to 0, the first value. And then x independent variable and y dependent variable. Right? X is the independent variable and y is the dependent variable. So that is why x is kept after the equal to symbol. Right? While training the model, when you are training the model, x is input training data, that is univariate. One input variable parameter must be taken. That is input training data, and then labels the data. Y always labels the data, that is supervised learning. Okay, it labels the data, what kind of data, apple or maybe what kind of it is. Then when training the model, it fits the best line to predict the value of y for a given value of x. The model gets the best regression fit line by finding the best a and b values, that is b intercept, and then a is the coefficient of x, b is the intercept, and b is the a is the coefficient of x. Once find the best a and b values, then the best fit line will produce, definitely the best fit line, whatever it may be, the line across your graph will be fit. Finally, using the model for prediction, it will predict the value of y for the input value of x. This is about the linear regression. Right? Linear regression, the values a and b must be chosen so that the error is minimum. Right? The error should be minimum. So here the sum of squared error is taken as a metric to evaluate the model. Then the goal is to obtain a line that best reduces the error. So whatever you have taken x and y values in this figure, right? So in this figure, so those are taken into consideration in one line, right? With the help of root mean square error and the mean absolute error. Root mean square error, that is RMSE yi minus yi bar whole square, that is sigma I is equal to 1 to n, 1 by n, number of samples, n means number of samples here, MEI, that is mean absolute error. The most suitable error in this linear regression is root mean square error, definitely. Mean absolute error is, of course, will be taken. Here, of course, here root we have taken, that is mean absolute error we have taken. The only difference is this only, right? Mean absolute, we have given root here and we have avoided this n is equal to number of samples that we give, and then y is the value when you get change, that is y is equal to labeling the data, right? So this is the linear regression equation. Dependent variable and independent variable, you can see dependent variable is on y-axis and x is on the independent variable. You should not get confused when When x means x comma y only we try to keep. X comma y, what is actually, what parameter should be kept in the x and what parameter should be kept in the y. So the parameter that you keep on x is independent variable that is going to have, that is x is equal to yb plus c, right? Yb plus c. Y is the dependent variable, that is right side of the equation. Okay, that we have to keep in mind always. Okay. Logistic regression, next one. The appropriate regression analysis to conduct when the dependent variable has a binary solution. Right? The perfect analysis or maybe perfect maybe prediction can be done only through the when the dependent value is a binary. Binary means here the values may be either 0 or 1. The value may be 0 or 1. If it is true or false, then you can, of course, if it is true or false means you will get accurate result definitely. Right? It is a classification algorithm that uses one or more independent variables to determine an outcome. You see that linear regression, logistic regression uses one or more independent variables. Right? Goal is to find the best fitting relationship between the dependent variable and set of independent variables. Merits are there. There is an excellent merit here. Understanding the influence of independent variables on the outcome of the dependent variable. And then demerits are only works if the predicted variable is binary, right? The predicted variable is binary, true or false. Which means you take that model, it is accurate result it will be giving you. Then logistic regression has binomial, multinomial, and ordinal. Target values are 2 in the binomial, multinomial 3 or more. Ordinal value deals with ordered categories, ordered only. I mean the ranges will be there. The values are given particularly. So it is also suitable for ordinal values. Remember binomial, multinomial, and ordinal values. So most of the time nowadays it is very good at very good at ordinal values, because we may give a category like any number of categories may be given, very poor, good, very good, excellent, extraordinary. Those kinds of categories may be given and can be analyzed easily through these regression techniques, right? The last regression we have hypothesis and the sigmoid curve. These two are these two important parts of the logistic regression. Definitely, hypothesis expectation can drive the likelihood of the event. Likelihood means here the possibility of something may be given or maybe be derived through this hypothesis. The equation is given in between 0 and 1. That is 0 less than or equal to 1. That is h of x, and then h theta of x and less than or equal to 1. So generated data can fit into a log function that creates a S-shaped curve known as sigmoid that converts any value from minus infinity to plus infinity to discrete value. You can observe here the curve S curve predicted y lies within 0 and 1 only. That is a hypothesis, right? S curve is given. You see S-shaped curve is given 0 and 1. Independent variable and dependent variable. Y is equal to 0 and 1 only value that you try to observe, right? Independent values of x are given here. Okay, you can observe in the diagram. It's logistic regression example. Now a clear explanation is given in this slide. The hypothesis of logistic regression tends to be limit the cost function between 0 and 1 only. Therefore, linear functions fail to represent it as it can have a value greater than 1 or less than 0, which is not possible as per the hypothesis of logistic regression. If you observe here, if there are inputs like x1 to x4, in the linear model, you see the linear model, you have probabilities of the values from in between 0 and 1. Then the sigmoid function is used, and then the values between 0 and 0.9 and 0.1. Finally, you will be leaving 0 or 1 only you are trying to predict. That is the first one, right? Then the sigmoid function f of x is equal to 1 by 1 plus e power minus x. Okay, 1 by 1 plus e power minus x. F of x is output between 0 and 1, probability estimate. X is the input to the function. E is the base of natural log. So logistic means the term itself, it is saying log. Log functions are used here, right? So sigmoid function, of course, into other than like another value between 0, maps any real value into another value between 0 and 1 only, right? In machine learning, it is used to map predictions to probabilities using the this formula, that is f of x is equal to 1 plus e power minus x, and this is the hypothesis expectation, right? And next one is decision tree. Decision tree, of course, we are aware of what a tree advantage, what a tree can have. The prediction results shows at the leaf node, which is given in the diagram. You can observe the decision node and decision node are there. Then you will have a subtree, and then follow the subtree, and then reach the leaf node, and you'll have a result. In this way, decision tree uses the features in the given data to perform supervised learning and develop a tree-like structure. Right? You will try to, and you will have branches and then connected to it. So here, in that way, the feature set, the decision tree can predict the expected output relatively accurately. Right? So you can observe clearly in this diagram. Accurately you can have, because so many decisions are taken at level by level, right? In the level by level, you will have feature set. That feature set or maybe feature selection happens. Once feature is selected, then you move to the down and then select some, maybe subset is there, you, or maybe subtree is there. You perform some actions and then go to the leaf node and have decision nodes, right? 2 or more branches, like let me go through those 3 points once. First, it breaks down a data set into smaller subsets. Of course, decision nodes are given between subtrees, and then decision nodes, 2 or more branches at leaf node, that is classification or decision is taken. The topmost decision node, that is best predictor called the root node, right? That is the decision node. That we know the one of the popular and very interesting tree is the decision tree kind of thing. Of course, based on the decision tree, we have there are several other display tree and all those. But this decision tree means here you take the decisions like true or false. That is why the output, whatever you expect, is accurate in this, right? Definitely, it will be accurate in the decision tree. Of course, C 4.5, C5, and all those are coming under decision tree category only, right? Those algorithms. Then decision tree, and we use entropy and information gain. There are 2 things which are always calculated in the decision tree. Entropy is a measure of purity of an arbitrary collection of information. Information gain, the amount of relevant information that is gained from a given random sample size, can be calculated. Right? These 2 things should be discussed elaborately here. Right? Entropy is the measure which is arbitrary collection of information. Arbitrary collection means there will be a tree generation. While tree is generating, you need to subset, or maybe subgroups may be formed while leaving the root node. While leaving the root node, you need to subcategorize or maybe subset the things. Then you will have a leaf node finally with yes or no decisions, right? Then information gain, the amount of relevant information that is gained. So what kind of information you have maybe gained or maybe collected in each and every level of the tree, that is information gain. So whenever there is, for example, level 0 or maybe level 1, level 2, level 3. At level 3, what kind of information you have gained, right? So that information is stored in the decision tree. And another point, entropy is used to calculate information gain. That is, of course, which is used to identify which attribute of a given data set provides the highest amount of information, right? So that is the main interestingness of the entropy is calculated from top to bottom. While calculating or while evaluating the procedure from root node to the leaf node, you try to identify a particular parameter or maybe an attribute. I can say that as an hyperparameter, which is used to generate more information that can be seen, that can be easily identified through the decision trees, right? And then the attribute which provides the highest amount of information for a given data set is considered to have more contribution towards the outcome of the classifier, and hence is given as the higher priority in the tree. That parameter is given the higher priority. A simple example is given here. to understand. So there are so many advantages are there. It is very specific, of course, very easy to use. But one point here in the decision tree, very difficulty about the decision tree, you have to design your own decision tree, right? You have to design your own decision tree to take accurate decisions. If maybe one parameter is falling left side of the root tree, but it is supposed to be in the right subtree means, so there will be so much variation while variations in the result you can see while observing the prediction. So it should be specific, and then of course it is easy to use once you know the predicted or maybe accurate output. Then versatilities, then resistant to data abnormalities, then visualization of the decision taken, right? Definitely applications are selective flight to travel, selecting alternative products, then sentiment analysis, energy consumption, fault diagnosis. These can be easily identified through decision tree. The limitations are sensitivity to hyperparameter tuning. I told you, I've been telling you, sensitivity to hyperparameter tuning is very difficult. Once you identify a parameter which is highly influential in the decision tree, that is a hyperparameter, that tuning must be done properly. So where exactly that hyperparameter may be used, that sensitivity or maybe that care must be taken while designing or maybe while taking decisions in the decision tree. Overfitting and underfitting. Yesterday, Sir was explaining excellently about overfitting and underfitting. Of course, I am having those also, overfitting and underfitting. We'll see. So I told you in the beginning, we how much training data set or maybe validation or maybe testing data set should be taken while on the data set. Right, the first step in developing machine learning model is to training and validation by participating data set, which involves choosing what percentage of data training or maybe validation and hold out data set must be taken. So that is you see that training set, that is 60 to 80% of the sample data used to fit the model training set. Then validation, the sample of data used to produce, right, and unbiased evaluation of model fit in the training data set while tuning model hyperparameters, that is validation set. Then training set, the sample of data used to provide an unbiased evaluation of final model fit in the training data set, right? So these are the 60 to 80, 15 to 25, and then 15 to 25% must be taken out, maybe must be taken from the data sets, right? So this is very important. Training, validation, and hold out. You can see the graph in 3 ways. Right, so this is underfit, overfit, and good fit. So already Sir has explained you yesterday. I'm skipping this. And then bias variance trade-off. This is a very important topic. I would like to tell you. Bias means what is it is the difference between the model's average prediction and the expected value. Okay, the difference between what is the model's average prediction. This is the prediction you are going to have, and expected value. Maybe, for example, your expected value is maybe around 40, but the average prediction value is maybe 35, something like, right? That is bias. Bias means biasing. Do not bias, we say na easily. That is the bias only here. Then variance in data is the variability of the model in case where different training data is used. Right, variance is nothing but accurate data set, or maybe the data set must be used. So if it is not in use, if the data set is properly not taken, then your results may not come. That is why bias variance trade-off is very important, right? You can see the characteristics of a biased model, that is underfitting, and then low training accuracy, inability to solve complex problems. Right, you will have inability to complex problems. It is very difficult to solve in the biased model, because biased model always expects near values, right? Nearby values, and may not be exact values, but near values it expects. Then characteristics of a model with variance, that is overfitting, low testing accuracy will have, over complicating simple problems. So if there may be simpler problems, but it becomes complications when you try to develop a model. Like underfitting, you can see the complexity and under simple example diagram is given. Right? Detection and solution to high bias problems if the training error is high. Right? You see that you can observe in the diagram low bias and then high bias, it is how it is infecting. Right? Train longer, train your model longer, then train a more complex model. Okay, then obtain more features, then decrease regularization, then new model architecture. These things must be followed when high bias problems are there. You need to focus on them. Then high variance problem occurs, then obtain more data. Here more data is necessary. Of course, in the bias, we have a data. We are in the training only now, then you will have a very simple, and there won't be any issues at all. Then decrease number of features, right? The number of features must be decreased. Then increase regularization, and then new model architecture must be done. These are the trade-offs that we need to follow. Once we couldn't able to get, maybe high bias problem is there, or maybe high variance problem is there, right? Then SVM, this is one of the perfect machine, or maybe perfect concept for machine learning algorithms, right? It is you can observe in the solving the regression and classification problems. Okay, solving a regression problems and classification problem. SVM is a powerful algorithm, which is the objective is to find hyperplane in n-dimensional space, right? Space that is n number of features that distinctly classifies the data points. Also to find a plane that has a maximum margin of the distance between data points of both cases. So this is a support vector machine. You can see in the diagram, right? So these are the types of SVM, which is linear SVM, then non-linear SVM, linearly separated, that you can see the blue lines are there and green lines are there, linearly separated, and non-linear separated, which are indirectly forming a kind of cluster, right? And then these are the Hinge laws, and then there is some formulas are there. Please go through the slides. I will share you. Let me give only 15-20 minutes left. This is an example of a kernel trick, and these are the applications of SVM in real model that you can go through. The Naive Bayes, let me hold for some time here. Naive Bayes, very powerful probabilistic algorithm. Probabilistic means here the probabilities were focused much on it means that nearby results are given accurate results through the Naive Bayes, right? The powerful, definitely predictive modeling classification for tasks based on applying Bayes theorem with the assumption of independence between every pair of features, right? Bayes theorem is given as like this: probability of A by the conditional probability that event A occurs given that B has occurred. That is termed as a posterior probability, P of A by B. P of A and B are the probability of A and B without any correspondence with each other. Then P of B by A, the conditional probability of the occurrence of event B given that A has occurred already. Right? Naive Bayes algorithm is very powerful, very excellent equation. P of A by B is equal to P of B by A into P of A divided by completely divided by then P of B, right? So this is Naive Bayes. This is algorithm clearly given likelihood, and then class prior probability, then predictor prior probability, posterior probability. The clearly posterior is equal to prior into likelihood, and then evidence. Proof is given at the bottom. Okay. These are pros and cons are there. Let us focus on the cons. Sometimes based bad estimator, because if the feature depend on each other or upon the existence of the other features, all of these properties independently contribute to the probability. If any feature you are going to select inaccurately, then your model gets out of your prediction, definitely, right? So the one of the best feature in this Naive Bayes is it performs well in I told you multi-class classification. Multi-class classification, Naive Bayes is excellent. It is very excellent algorithm to identify. Of course, like it is given, of course, multi-class prediction, real-time prediction, and then recommendation systems is also useful, text classification, spam filtering, sentiment analysis as well, right? K nearest neighbor, which is also the one of the very important one to distinguish parametric and then non-parametric methods. Like parametric means here, maybe falling under supervised learning, and non-parametric means here unsupervised learning. So here we have to categorize. So which your K nearest neighbor is suitable, that we will see anyhow. KNN is widely used as a non-parametric, which means it does not make any underlying assumptions about the distributions of data. Right? It is a lazy learning technique, but very powerful technique. If there is unsupervised, maybe unsupervised kind of data is there, which is of course labeled, but cannot recognize it easily. Again, it is distributed. It should learn itself, and then it should be able to predict the data. So who are nearby, and then what decision should be taken. Wonderful steps, 5 steps are given here. Determine the value for K. That is, the K is the number of nearest neighbors, right? Who are the nearest neighbors are there. Then calculate the distances between the new point, right? What is this distances? Distances, there are so many equations are there. Maximum likelihood, or maybe there are so many equations which uses to find out you have to follow only that particular formula to find the nearest neighbors, and then stick to only those. Even in the clustering also, we consider the distance measures as well. We consider the distance measure as well. Based on the distance measures only, we try to group the things, collect things. In the same way, in the K nearest neighbor also, we try to see that what are class A, or maybe what are class B, or maybe class C, some kind of categories. We keep the data in the appropriate number. K is the odd number if the number of classes is 2. Right? K will be the odd number if the number of classes is 2. Remember that. Okay. So K nearest number, these are the merits and demerits, very well known. So of course, demerit, let us see. It is not suitable for large dimensional data. That is the drawback of this. Right? Testing phase is slower and costlier with respect to time and memory. The high memory requirement is required because labels are given continuously to this model. Right? Okay. Next, optimization. Optimization is a process of searching for parameters that minimize or maximize our functions. Okay. Generally, ML or DL model usually use indirect optimization. Certain metrics like accuracy, precision, recall indicates how well our model solves given problem. So based on the accuracy and precision, or maybe recall, we see the optimization techniques, right? Here, optimization, first order optimization, that is gradient descent algorithm, one of the mostly widely used gradient. We'll try to find the loss function in that gradient descent algorithm. Second order optimization algorithm, that is second order partial derivatives, Hassan matrix. Hassan matrix is one of the very popular algorithm to generate this optimization. And then gradient descent explanation is given. And ensemble learning, finally. Ensemble methods aim to improve predictive performance of a given statistical learning or fitting technique, best fitting techniques. Ensemble is nothing but here a mixture of all predictor values like noise, variance, and bias. So these all are focused together, and of course it is a supervised learning algorithm, right? It is a supervised learning, and if it is not supervised, then there is no ensembling method. So wherever ensemble methods are there, these should fall under supervised learning algorithm. These are the bagging and boosting are one of the best techniques of ensemble. Boosting and bagging, right? Random forest algorithm, bagging, and then gradient boosting. Gradient descent, not gradient descent, gradient boosting here. Gradient boosting is one of the best algorithm. Okay. So here, these are the methods of ensembles. Right. Another one is this is the Supervised versus unsupervised algorithm, like, comparison input data is labeled data and unsupervised is unlabeled data. Computation complexity is very high in supervised, then less complexity in unsupervised. Real-time usage, where uses of offline analysis and use of real-time analysis. No number of classes are known here, and then unsupervised, that we know they are unknown. Then accuracy of results is accurate and reliable, moderate and reliable in unsupervised. Category is classification and regression. We have seen clustering and association rule mining. Okay. So this is an important slide to show you the most popular machine learning tools which are given. Platform, you can observe here, right? You see Scikit Learn platform, the cost, it is free of cost. Then the written language is in Python. Algorithms are features. Of course, these are the classification, regression, clustering, pre-processing, model selection, dimension. This is an excellent site to show you what kind of tools are used and where and who has implemented and which platform you can develop. This slide shows you clearly. I have taken from internet source only. There is no special. Then PyTorch is given, TensorFlow. Sai Satish sir have gone through this, all these platforms: PyTorch, TensorFlow, Weka, Naim, and Colab. Everything used almost. Keras also, RapidMiner. I think we have not used Shogun and Hackers.net. Right, remaining all mostly used to explain all these concepts with the real-time data. That was excellently given. Okay, and let me move towards the next slide. Right, so this is a small diagram to show you, nothing else to explain. That's it. So this is also a cheat sheet, the final cheat sheet to learn about machine learning techniques. This is very nicely given by Microsoft in 2021. What do you want to do actually in your machine learning? Do you want to predict results? You go to predict values and have regression technique. See that? Then what do you want to do? Exact information from text. If you want, you go to text analytics, and then latent, digital like allocation, extract, engram, feature hashing, preprocessor text, word to vector. These are there. And then if you want to have predict between several categories, that is multi-class classification, I told you now, this multi-class logistic regression, multi-class neural network, multi-class Bayesian forest. This excellent cheat chart is given. Please go through this. With this, I would like to thank you all for giving me this opportunity, wonderful opportunity. I was in a hurry to move to, there is a meeting now. I need to move to the department to handle that meeting. Thank you very much, sir, for giving this opportunity. And I thank the management for showing interest towards the machine learning concepts. And I hope you will do some international conferences and more programs in future also. Thank you very much.
Thank you, sir. Thank you so much for enlightening us with your knowledge and words.
Thank you, sir. Thank you very much for joining as a faculty today.
Yeah.
So dear participants, please hold for a couple of minutes. We'll be sharing the attendance sheet for certification purposes. Just give me 1 or 2 minutes.
Yeah, shall I leave, sir?
Yes, sir. Yes, sir. Thank you.
Thank you,
Very much.
Sai Satish sir. Thank you very much. Thank you very much.
Thank you. Yeah, dear participants, please wait for 1 or 2 minutes. We'll be sharing attendance sheet. Please check the chat box. We have posted a link for posting your attendance. Within 3 or 4 days, you will get SMS with the link of your certificate, participant certificate. Please check the chat box. Thank you very much for all the faculty and participants who joined in this program. Within 2 minutes, we are going to end the meeting. Please check the chat box. Link has been posted. Please post your details in the chat box. In the attendance form. And please stay in the WhatsApp group. We'll continue posting all the useful information related to AI. Ending this session in a minute. Please check the chat box. We have posted a link for attendance. PPTs, we have to ask Satish sir. We will share some cheat sheets today. All the upcoming programs will be posted in the same WhatsApp group. Please stay in the same WhatsApp group. Yes, machine learning cheat sheet will be posted in 1 or 2 minutes in our WhatsApp group. Yeah, within 30 seconds, we are going to end the meeting. Hope everyone filled the attendance. Within 3 or 4 days, you will get SMS with your certificate link. Thank you very much for joining. Ending the meeting. Thank you. Bye all. Madam.
Thank you,
Sucharita,
sir.
madam. Yeah, welcome. Thank you.
Sir, there is a vote of thanks, sir.
Yeah, please continue.
Ladies and gentlemen, a very good afternoon. It gives me an immense pleasure to deliver the vote of thanks on the Faculty Development Program for Advanced Algorithms and Applications. To all the participants assembled here, I would like to thank the resource person, respected Dr. B. Satish Kumar Garu, Professor, Computer Science and Engineering in Jawaharlal Nehru Technology University, Hyderabad, who despite his busy schedule has found time to grace this occasion and honor this event not only with his inspirational thoughts, but also enlighten us with their commendable talk on subject. Thank you, sir. We specially thank Sai Satish sir, CEO, Indian Servers. I would like to thank our beloved principal, vice principal, head of the department, staff members for making this event as a grand success. Once again, I thank one and all present here. Thank you, sir.
Thank you. Thank you all. Bye.